Hello there, welcome to science class. In today's lesson, we shall be discussing lowest common multiple. Lowest common multiple, LCM. I know the word lowest is familiar to us all and common is also familiar to us all. But what about multiple? What is multiple of a number? This simply means a number that is the product of a given number and some other natural number. In our last class, we discussed what natural numbers are. So, multiple of a number simply means a number that is the product of a given number and some other natural numbers. And when you talk about product in mathematics, it simply means multiplication. Example of multiple is when you have 6 times 3, for example, is 18. 6 times 3 is 18. So, 18 is a multiple of 3. And 18 is also a multiple of 6. What this means is that 3 can be multiplied by a particular number to get 18. Also, 6 can be multiplied by a particular number to get 18. So in this case, 6 and 3, when multiplied together, gives us 18. So 18 is a multiple of 3, and 6 and 18 is also a multiple of 6. 3 is a factor of 18. 6 also is a factor of 18. So, multiple of a number is equal to the number or greater than the number. So, multiple of a number that is equal to that number is simply that number multiplied by 1, which remains the same value of the number. For example, 6 times 1 is 6, 3 times 1 is 3. So the first multiple of 6 is 6, which is 6 times 1. Any other multiple apart from 6 times 1 is usually greater than 6. Now, what is LCM? Given a set of numbers such as maybe A, B, C, D, these are just alphabets representing numbers. The A could be just 3, 4, 5, 6, 7, 8, 9, 10, 12, 11, 13, 14. It could be any set of number. So I said, given a set of number A, B, C, D, the LCM is the smallest or lowest number n, such that n is a multiple of the given set of numbers. So what I mean here is, given a set of numbers, the lowest common multiple is that multiple that is common to all the numbers given. The lowest multiple of all the numbers given. Remember, I told you that multiple of a number is either equal to that number in the case of that number multiplied by 1 or greater than that number. So, given a set of number A, B, C, D, the LCM is the smallest or lowest number n, such that n is a multiple of the given set of number. Any multiple of a given set of number such that is the lowest is the LCM. Example, let's go to our example. Before we go to our example, there's something we need to also discuss quickly. This is what we discussed in the last class. That is the prime number. The prime numbers are very important in LCM. Prime numbers are numbers like 2, 3, 5, 7, 11, 13, 19, etc. Whenever you see 3 dots in mathematics, it means that that sequence continues. So just as a recap, a prime number is a number that can only be divided by itself and 1. For example, 2 can only be divided by 2 and 1. 3 can only be divided by 3 and 1. 5 can only be divided by 5 and 1. And that is how it continues. So when calculating LCM of a set of numbers, we deal with prime number. That is, we use prime numbers to divide each of the numbers and then get how many times is particular prime number divide such number, and then we move to the next prime number and use it to divide the number. And when this next prime number can no longer divide the number in question, we move to a higher prime number. I know this might seem confusing, but let us just go to the example. Example 1 says, find the LCM of the following number: 2, 4, 12, and 16. 2, 4, 12, and 16. All right, so the first number here is 2. The first number here is 2. So we can see here, the first number here is 2. So now, this 2 and the first prime number is also 2, as I told you the other time. So you pick the smallest prime number and check if it can go in 2. So 2, this 2 divided by this 2, it can go 1 time. Then 1 in 1 goes 1 time. So the prime factors of 2 are 2 times 1. Prime factors of 2, just 2 times 1 as indicated here. 2 times 1. Then the second number in the series is 4. This is 4. Then you put your 4 here and you begin to divide. The smallest number that you pick from the prime number you try is 2. So 2 can go in 4. So 4 divided by 2 gives you 2. Then this 2 again, you use 2 again. Since you've not gotten to 1, you continue to divide the number by prime factor until you get to the point where you have 1. So 2 divided by 2 again gives you 1, and then 1 divided by 1 gives you nothing. So the prime factors of 4 are 2 times 2 times 1, and 2 times 2 times 1 will always give you 4. The next number is 12. 12. Now this is 12 here. So if you pick the smallest prime number, which is 2, and use it to divide 12, 12 divided by 2, it will go 6 times. Alright, 2 can still go in 6. So 6 divided by 2 to give you 3. Can you see? Gives you 3. So can you see when you get here, realize that 2 can no longer go. So you move to the next prime number, and the next prime number is 3. So 3 divided by this 3 gives you 1. 1 divided by 1 gives you 1. So that's the end. When you get to 1, dividing the prime number by itself, then you stop the division. So 3 in 3 gives you 1. 1 in 1 gives you 1. So that will end this series. So 12 will be 2 times 2 times 3 times 1. And where did I get all this multiplication that I'm doing? Here is it here. 2 times 2 times 3 times 1. So those are the prime factors of 12. Let's go to the next number. The next number is 16. So quickly here, 16 16 divided by 2 gives you 8. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. 2 divided by 2 gives you 1. Understand? So you have 2 going 4 times. So you have 2 going 4 times. 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 in 2, 1. So 2 times 2 times 2 times 2 gives you 16. Here is it. 2 times 2 times 2 times 2 gives you 16. Now, we now break it down. So here is written 2. And the first number is 2. So the prime factors are 1 times 2. 4. The prime factors are 1 times 2 times 2. 12. The prime factors were 1 times 2 times 3. 16. The prime factor was 1 times 2 times 2 times 2 times 2. Now, how are you going to get the LCM? You are going to get the LCM by what is common to all these factors. If you realize 1 is common to all of them, 1, 1, 1, 1. So you write your 1 here, 1 times. What is common again? 2 is common to all of them. You can see 2 here, you can see 2 here, you can see 2 here, you can see 2 here. That's the first 2. Can you see? It's having 1 on top. It's having 1. It's having 1. It's having 1. So 2 is common to all the factors. 2 is common to all the factors. I can do it like this. 2 is common to all of them like this. Can you see? Then you put that 2 that is common to all of them. You put it here. Now, you are done with 2. You come here. You see another 2 here. That 2, you can see there is no 2 here again, but there is another 2 here. So you are picking the second 2s. So can you see 2 on top of this, 2 on top of this? So you are picking the second 2s. So this and this makes the second 2 here. 2 times 2 times 1. 1 times 2 times 2. Right? Now, you're done with this guy. Here, on this 16, you still have another 2. You still have another 2, which is 2 number 3. 2 number 3. See? So you put the third 2 here. The third 2. 1 times 2 times 2 times 2. 2 number 3. You are done with that. If you check 16 again, you see there is another 2, which is the fourth 2. The fourth 2. So you bring that 2 and put it here. Now you are done with all the prime number 2. The last thing you need to now put is the next prime number, which is 3. That 3, you bring it here. All right. So you now multiply all the numbers together. 2 times 2 times 2 times 2 times 3. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. So the LCM of 2, 4, 12, and 16 is 48. In the second example here, we have LCM of 6, 9, and 12. 6, 9, and 12. So the first number is 6. So 6 divided by 2 is 3. 3 divided by 3 is 1. So that is the prime number. Then the next number is 9 divided by 3 is 3. 3 divided by 3 is 1. Then the next one is 12. 12 divided by 2 gives us 6. 6 divided by 2 gives us 3. 3 divided by 3 gives us 1. Now, notice that all the number you are using to divide these numbers, bigger numbers, they are just prime numbers. They are prime numbers that you use to divide. So, learn to use the prime number. And when a smaller prime number is not going to, you go to the next prime number, the next bigger prime number. So from here we can see 6 is 1 times 2 times 3. 9 is 1 times 3 times 3. 12 is 1 times 2 times 2 times 3, all in prime numbers. So if we now want to get the LCM out, you know that 1 is common to all of them. 1 is common to all numbers, so we can leave that out. So this is the first 2 in here. You can see 2 number 1 here. Here does not have any 2, so we leave it out. Here has 2. This is another 2 number 1 here. So this 2 number 1 and this 2 number 1, see it here, 2. Then you check here again. You check here again. You don't have 2 here any longer. You don't have 2 also any longer here. This is the next place you have 2. So this is the second 2 here. This is 2 number 1. This is 2 number 2. So that 2 number 2, you bring it down here. Then 2 has been exhausted. Then you move to the next prime number, which is 3. This is 3 number 1 here. Can you see? This is 3 number 1 here. Can you see? This is 3 number 1 here. If you notice here, you have only 1 3 here. You have only 1 3 here. You have 2 3s here. This is 3 number 1. So all 3 number 1, 1, 2, 3, they fall under this 3. They comes here. Then this last 3, which is 3 number 2, comes here. So you come here and multiply all through. 1 times 2 is 2 times 2. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So the LCM of 6, 9, and 12 is 36. The LCM of 3, 9, and 12 is 36. The next example is LCM of 4, 14, and 21. So 4, 14, and 21, this is 4. 4 divided by 2 gives you 2. 2 divided by 2 gives you 1. And that's the end. 14. 2 divided by 14 is 7. 3 cannot go in 7. So we'll jump to the next prime number, which is 5. 5 cannot go in 7. So we jump to the next prime number, which is 7. 7 can go in 7. It goes 1. And that will be the end. Then, this is the next number, 21. 2 cannot go in 21 because 21 is an odd number. 2 cannot go. So we'll go to 23, the next prime number. 3 can go in 21. 21 divided by 3 gives you 7. Then 7 divided by 7 gives you 1. Alright, so we break it down. 4 is 1 times 2 times 2. 14 is 1 times 2 times 7. 21 is 1 times 3 times 7. So 1 goes in all of them. This is your 1. My next example, I'm not going to put 1 again because 1 always goes in all numbers. Then this is the first 2 here to number 1. This is first 2 here to number 1. This one does not have 2, so you don't need to write 2 here. So these 2 and these 2, this is it here. This is the second 2 to number 2. This one does not have any 2 again. This one does not have any 2 again. This 2 number 2 that is here is here. Then going to 3. 3 number 1. This is 3 number 1 here. This guy does not have a 3. This is the only guy that has 3. 3 number 1 is here. So this is the 3. Then this guy and this guy has 7. 7 number 1, 7 number 1. This guy does not have 7. So 7 number 1, 7 number 1. This is his here. So 1 times 2, 2. 2 times 2, 4. 4 times 3, 12. Then 12 times 7 is 84. So the LCM of 4, 14, and 21 is 84. Our last example for this class, LCM of 12, 15, and 18. LCM of 12, 15, and 18. This is 12. 12 divided by 2, 6. 6 divided by 2, 3. 3 divided by 3, 1. So 15. 2 cannot go in 15. So 3 in 15 go 5. 5 will go in 5, 1. Then coming to 18. 18 divided by 2 gives us 9. 2 cannot go in 9, so you go to the next prime number, which is 3. 9 divided by 3 gives us 3. 3 divided by 3 gives us 1. So here, 12 is 2 times 2 times 3. 15 is 3 times 5. 18 is 2 times 3 times 3. So this is the first 2 number 1 and 2 number 1. This guy does not have 2. So this 2 number 1 and 2 number 1, see it here. Then this is 2 number 2. This guy does not have 2. This guy does not have 2 number 2. So this number 2 here, see it here. Then 3 number 1, this is 3 number 1 here. This is 3 number 1 here. This is 3 number 1 here. This gives us this 3. 3 number 2 is here. 3 number 2, can you see 3 number 2? This is it here. Then the last number, which is 5. 5 number 1. No any other of the number has 5. So this guy is the only one that has 5. 5 number 1. And this is hit here. So the LCM of 12, 15, and 18 is 2 times 2 times 3 times 3 times 5, which is 180. 180. Thank you for watching this lesson. The LCM is going to be needed in solving addition of fractions and so many other things in mathematics. The class is a bit long, but I want to believe you enjoy the class. If you have any question, please drop your question in the comment section. I'll be waiting to answer your questions in the comment section. And please don't forget to subscribe to the science class. Thank you for the watching video, and see you in the next lesson. In the next lesson, I'm going to be discussing a shortcut method of getting the LCM solved. We're not going to be going through a very elaborate method as this. So if you want to know the shortcut method of solving LCM, then you have to watch my video on the shortcut method of solving the LCM. See you there. Bye.